Good afternoon. We'll be continuing the lecture which we had abruptly ended, which we had ended yesterday. So this is modulus of mod x minus 1 minus 5 less than equal to 2. So if we have to solve this question, let's recap what we had covered yesterday. Let's say this is the modulus operator. If I'm entering x, then the output is going to be modulus of x. As we remember, x का अगर mod लिया जाए, the output is positive x if x is greater than 0 and minus x if x is less than 0. Since plus 0 and minus 0 mean the same thing, then either I can put equality in the first condition or I can put equality in the second condition. It would mean exactly the same because plus 0 and minus 0 are the same thing. If I'm inputting 0, what will be the output? Again 0. So irrespective of 0 being in the positive condition or in the negative condition, the output is always going to be 0. If I input anything that is greater than 0, that is a positive value, then the output will be a positive integer or any positive real number. If the input is a positive integer, is a negative integer or a negative real value, then the output will still be a positive real number. So let's move forward and try to visualize what the question is saying. The question is saying, let's say there is an expression of x which is less than equal to 2. अगर उसका mod लिया जाए, that means modulus of capital X, that is the expression, will always be less than equal to 2. This means the output is always less than or equal to 2. What does that imply? That the value of x is less than 2 or and the value of x is greater than minus 2. It implies that the input should lie between minus 2 and 2. Only then will the output be less than or equal to 2. So we can write it as modulus of x minus 1 minus 5 lies between 2 and minus 2. So it has to be less than or equal to 2. At the same time, it has to be greater than or equal to minus 2. These two conditions are necessary and sufficient because the value of this expression should lie between the point x equals 2 and the point x equals minus 2. When the value lies between these two extremities, only then the modulus of that value would be less than or equal to 2. Let's proceed with the question. I'll write condition number 1 over here. Minus 2 is less than or equal to mod x minus 1 minus 5. Let's add 5 to both the sides. I will get 5 minus 2, that is 3, less than equal to modulus of x minus 1 ka whole mod. Now let's try to visualize this thing. Modulus of this expression is greater than or equal to 3. If it is greater than or equal to 3, what does that imply? That the value is either greater than 3 or it is less than minus 3. Now the difference is there is a word or. If the value of modulus has to be greater than 3, if it has to be greater than 3, either it is more than 3 or it is less than minus 3. So I'm going to say either x minus 1 is less than what value? It should be less than or equal to minus 3, or this expression x minus 1 should be greater than or equal to 3. When either of these conditions is true, then this condition would be true. So if I have to solve, I'll say x is less than equal to, adding 1 to both the sides, I'll get minus 2 over here. And if I have to calculate this, I'll add 1 over here. So I'll get a 4. So x belongs either less than minus 2, that is from minus infinity to minus 2, closed interval, open interval, union, because there is a choice between these two intervals. And the second choice is going from 4 to infinity, open interval, closed interval. So either x belongs to this or to this. Now let's try to visualize condition number 2. If I have to solve for condition number If I have to solve for condition number 2, let's have a look at this. For condition number 2, I have written this thing. This is what we are going to use. That is modulus of x minus 1 minus 5 should be less than equal to 2. That means mod of x minus 1 should be less than equal to, adding 5 to both the sides, I'll get 7. Now if modulus, the value of modulus is less than or equal to 7, what does that imply? Let's try to visualize it in the graph itself. If the output is less than 7, it means that the value will lie between minus 7 and 7. Only then it is possible for the modulus output to lie between 7 and 0 if the input lies between minus 7 and 7. So I'm going to say for the modulus to be less than or equal to 7, the input should lie between minus 7 and 7. Let's try to visualize how this would look. X minus 1 should lie between 7 and minus 7 for the modulus of this thing to be less than or equal to 7. So now we are going to create the two conditions. Adding 1 on both the sides, I'll get minus 6. And again, I'll get this as the second expression. Adding 1 to both the sides, this will be the final expression. So now these two conditions have to be satisfied together in order for this condition to be true. So I'm going to write that x is greater than or equal to minus 6, less than or equal to 8. This will be a closed interval. So it can also be written as x belongs from minus 6 to 8, closed intervals. So now, as we were seeing, x, the value of x is such that it has to satisfy condition 1 as well as condition 2. So now in this interval, which we calculated in case 1, and in this interval, we have to look for the common parts because they have to fulfill both these conditions. Let's try to visualize how such a thing is going to happen. I'm going to draw a common number line representing both of them, minus infinity to minus 2 and 4 to infinity. Then I'll change the color for the second condition. It will be minus 6 to 8. Minus 6 lies somewhere over here and 8 lies over here. So it is minus infinity to minus 2, closed interval. Then from 4 to infinity, again closed interval, goes till infinity. Now let's have a look at the other interval. It is from minus 6 to 8, closed intervals. So this will be the second number line. Now we have to look for values such that both of these conditions are satisfied. Both of these conditions are satisfied for this interval and for this interval. So I'm going to say x belongs from minus 6 to minus 2 union 4 to 8, closed interval, closed interval. I hope that is enough. If there are any questions, I would like to answer them. Okay, let's move ahead and try to solve the second question. If the expression says that modulus of something is greater than equal to 2, let's visualize it through the graph. If the output is greater than 2, that means this is the output. For this output, the input should either be greater than 2 or should be less than minus 2. If the output of modulus is greater than or equal to 2, that means the input would have been more than 2 or the input would have been less than minus 2. So I'm going to write it as x minus 2 upon x minus 4. It is either less than minus 2 or this thing x minus 2 upon x minus 4 should be greater than or equal to 2. If either of them is satisfied, then the condition would be true. Now let's try to solve this. I'll write it as x minus 2 upon x minus 4 plus 2 less than equal to 0. Why am I not cross multiplying? The reason was discussed in the earlier lectures. Now let's move forward. This is x minus 2 plus twice of x minus 4. Then in the denominator I'll write x minus 4 less than or equal to 0. This becomes x minus 2 plus 2x minus 8 upon x minus 4 less than equal to 0. I'll solve it over here. X plus 2x is 3x, minus 2 minus 8 becomes minus 10, divided by x minus 4 less than or equal to 10. So now if I'm saying that modulus is greater than equal to 2, it should either be greater than 2. We created this it should be greater than positive 2. It should be less than or equal to minus 2. The condition is true. Now let's move forward. I'm getting 0 over here. Why did I write 10? This is less than or equal to 0 over here. Fine. Maybe I might have copied 10 from here to there. Let's see. 3 x minus 10 upon 3 divided by x minus 4 less than equal to 0. So in the standard form, it becomes x minus 10 upon 3. I'll multiply numerator and denominator by x minus 4. This is less than equal to 0. Now let's see. This became a positive. This x minus 4 ka whole square. This will always be positive. That is the reason why both the sides can be multiplied with it. If I'm multiplying both the sides with x minus 4, then I get square in the denominator, which will always be a positive number, and I can multiply LHS and RHS with that positive number. But the condition I have to remember is that x should not be equal to 4. If x becomes 4, the expression becomes undefined. So in order to solve it further, I'll use the space. I'll write over there x minus 10 upon 3 multiplied with x minus 4 less than equal to 0. Now let's try to plot the roots. One root is going to be 4 and another root is 10 by 3. This is going to be positive, negative, positive. Less than equal to 0 symbolizes the interval between the two roots. So I'll say that x belongs from 10 to 3, say 4. We are going to put closed intervals. This will be the answer to the first condition. I'll make some space for the second part. Okay, let's proceed. I'm having x minus 2 upon x minus 4 minus 2 greater than equal to 0. Over here I'll write x minus 2 minus twice of x minus 4 divided by x minus 4 is greater than equal to 0. This becomes x minus 2 minus twice of x plus 8 whole upon x minus 4 greater than equal to 0. I hope it's clear till here. Let's move forward. X minus 2x is minus x, minus 2 plus 8 becomes plus 6 divided by x minus 4 greater than equal to 0. So now this is the simple condition. it can be written as x minus 6 upon x minus 4 is less than equal to 0. If I multiply numerator and denominator by x minus 4, I can write it as x minus 4 divided by x minus 4 ka whole square less than equal to 0. This is a positive term. Both the sides can be multiplied with it and still there won't be any change. It's just that we have to remember x cannot be equal to 4, otherwise it becomes undefined. So over here I'm going to place an open interval. Let's move forward. Over here I'll get x minus 6 and this is going to be x minus 4 less than equal to 0. The two roots are going to be 4 and 6, positive, negative, positive. The value is going to be between 4 and 6. That is when the interval expression is going to be less than or equal to 0. So if I have to plot that point, I'll say x belongs from 4 to 6 closed intervals. In this interval, the value is going of that expression is going to be less than equal to 0. We are talking about this expression. But one thing we have to remember that if x takes the value of 4, the original expression becomes undefined. So I have to exclude 4 from the answer. Hence my final answer will become that is first condition is this and second condition is if I have to solve for mod of x is greater than minus 5. Obviously mod is always positive. If it is always positive, it implies that a positive number is greater than a negative number. What does that imply? Always true. If it is always true, I can say that x